Okay, so right now we're going to be looking at how to turn a position versus time graph that we're given into a velocity versus time graph. So sometimes we need the velocity versus time graph. It's more convenient for the analysis that we want to do, but sometimes position versus time graphs are what we given or they're easier to make. So first, let's go ahead and analyze this position versus time graph. Okay, so from 0 to 10, its position changes constantly. Okay, at 10 seconds, it is 60 meters away. It stops for about, looks like it's right in between 10 and 20. So for about 5 seconds, it is stopped. Okay, then it starts traveling backwards. It travels all the way down to negative 40 at 40 seconds and then goes back up to where it started. Okay, so in order to change this into a velocity versus time graph, basically what we have to do is we have to divide this graph into sections, okay, into the most natural sections. So section 1 is going to be this first flat part here, okay, from 0 to 10 seconds. Okay, we need to know its velocity during that time. Okay, so how far did it go? What's its rise? It's 60 meters over, how long did it take? 10 seconds, okay? Our time is in seconds. So during that time, its velocity is 6 meters per second. Okay? Chunk 2 is this little flat part right here. Okay? So part 2, I'm going to go ahead and label these on the graph for you too. Okay, so this is chunk 1. This little bit is chunk 2. Chunk 2, its position doesn't change. Okay, it stays at 60, so its rise is 0. Therefore, its velocity is 0 meters per second. Okay, it's stopped. Okay. Oh, and that stopped, sorry, I forgot to write the time, from 10 to 15 seconds. Okay. Now let's look at chunk 3. Okay. In chunk 3, it has this pretty flat part here. So that's from 15 seconds all the way to 40 seconds. Its rise, or how much it changes, is from 60 to negative 40. Okay, so 60 minus negative 40, okay, that gives us 100 meters. Okay, so its position changed by 100 meters. And that time we said it was from 15 to 40. So 40 minus 15, that gives us, I should be able to do this in my head, 25. Okay. 25 seconds. So 10 divided by 25 is 4 meters per second. Okay, but it went down during that time. Okay, it's going backwards. It's going the opposite direction. So that's going to be negative 4 meters per second because its slope is now negative. Now let's look at the fourth chunk right here. Okay. In chunk 4, okay, it goes, that is from 40 seconds to 50 seconds. Okay, it goes from negative 40 back to 0. So we have 10 meters. That's its rise over, that's 10 seconds. So if it, oh, I'm sorry, I lied. 40 meters in 10 seconds. So it's going at 4 meters per second, but it's going back up, okay? So its velocity is positive again. Yep, 40 meters. And that makes sense. If we look at just these little slopes right here, they're equal. They're opposite in direction, but they're equal in magnitude. The slopes are the same. So it makes sense that the speeds are the same. Now these speeds are what belong in our velocity versus time graph. So its fastest speed is 6 meters per second. Okay, it is at 0 for a bit, and it's also at negative 4 meters per second. So that's going to help us set up our scale for our velocity versus time. and it's still over this 50 seconds. The time doesn't change. So let's go ahead and set up our scale. Yep. Gonna put that right in the middle because I know I'm gonna have to go positive and negative with this. So this is my time in seconds, and now on this axis it's my speed, and all of our speeds were in meters per second. Okay, so this is velocity or speed in units of meters per second. Okay. So my time, I'll just do the same scale, 10, 20, 30, 40, 50, and then we'll go out to a full minute just because. And then if I know I have to go up to 6, I'm going to do it by 2s. So 2 meters per second, 4 meters per second, 6 meters per second. And then we have -2 and -4. Okay. Notice in our position versus time graph, all of the lines are straight. Okay. Whenever we have a straight line, that means it's going at a constant velocity. It's not like it starts out covering a lot and then gradually slows down. Okay, it's a straight line. Every second or every 10 seconds, it's covering the same amount of distance. So straight lines mean constant speeds, which will lead to like a staircase-like effect on our velocity versus time graph. Okay, so let's start with our first section. From 0 to 10 seconds, it went 6 meters per second. So 0 to 10, it was up here at 6 meters per second. Okay, and then it went down to 0 for 5 seconds. And it didn't gradually slow down, it cut straight down to that. Okay, and then it was at -4 seconds, all the way up until time 40 seconds. Okay, and then it started going back up the other way, and it was at +4 meters per second. Okay, so it starts off fast, and then it stopped, and then it moved in the other direction, and then it moved in the other direction. Okay, if you look at this graph, it went forward, it stopped, it went backward, and then it went back toward its origin. Okay, they're the same graphs and the same chunks. They mean the same thing, just talk about it in different ways. And through this, you can see some kind of cool things. For example, okay, if we looked at part 1 on the velocity versus time graph, the area under that from 0 to 6, 10 seconds, it would be 10 times 6, or 60 meters. So we know that it traveled 60 meters in that time. We could have also told that more easily on the position versus time. At 10 seconds, it was 60 meters away. Okay? But the area on a velocity versus time graph takes you back to the position. The slope of the position gives you the velocity. Okay? This could allow us more easily, because if we looked on this one, okay, if we went from 3, say we were doing this one, between 15 seconds and 40 seconds, it went from 60 to -40. It covered 100 meters. Let's look at it over here. 15 to 40, okay, that's 25 seconds. And 4, so 25 times 4, what do you know? 25 times 4 is 100 meters. Okay, that area will always give you the distance covered. Okay, so area takes you back to this, slope of this takes you back to this. It's basically just derivatives and integrals if you've had calculus class before. But that's how we turn a position versus time graph into a velocity versus time graph.